Hello and welcome to Education at SSBJ Online Video Tutorials. We are here to understand a very important law through demonstration, and that law is Ohm's law. Right? And when you state this Ohm's law, we are going to come across certain concept such as voltage, right, and current, then the resistance. So if you can give a symbol V for voltage, then I will be for current and R is for resistance. So this Ohm's law states the relationship between these three, which means to demonstrate Ohm's law, we have to measure voltage, we have to measure current, and we have to calculate resistance and derive the conclusion which shows the relationship between voltage, current, and the resistance. Right? Now, before we straightway start doing the practical session on the demonstration of Ohm's law, it is better always to just recall the theoretical aspects of voltage. In short, what is current, what is the instrument to measure voltage, and then what is the device to measure the current. And what do you mean by resistance? Right? So let me tell you one by one. In short, let's not go in detail because you have already studied this in detail in the theory of class 10th. So now I'm going to go for about resistance. In simple words, let us try to understand what is resistance. Right? So first one is resistance. Resistance is a property of a metal. And what is that property? A property to oppose the flow of current. We all know that when the charge flow, let's say when the charge flow in this direction, I am denoting this as E. Okay. So when the charge flow in this direction, there is some property for every metal which opposes. Okay. Which opposes, and that is the property which doesn't allow the current to flow smoothly. And that property is what is resistance, and which is a measurable quantity. Okay. And resistance is different for different metals. Now I have a copper wire here. Its resistance is different than a wire which is winded. I'm going to open this here and show you what is there inside. Look at this. And I'm going to open on this side also so that you should know that what is there inside. Okay. This is the coil. Right? And that coil is here, you can see, connected to this terminal, whereas this side is connected to this terminal. So when you get this particular object or a device or say a material in your lab, then you should ensure that there is a proper connection between. Sometimes we don't have a connection here, direct connection here, so we will not get the proper values. So it's a metal. It may be an alloy or any other kind of metal which has some resistance, okay, which has some property of opposing current, just like a copper wire. Copper wire also opposes current. But among these two, this opposes more. And therefore, Since this particular coil has got more resistance, we generally call that coil as, so this is called as resistor. Right? So we can call this as a resistor. Right? Now, the unit which is measured, which is used to measure this resistance is ohm. So remember this. So unit to measure resistance is ohm, and the symbol is this. Right. Now we don't know what is the exact value of resistance of this. Right? And that is what we are going to measure when you conduct an experiment demonstrating Ohm's law. Right? So one point is very clear now. We have understood what is the resistance. Resistance is the property of any conductor to oppose the flow of current. Right? More the less resistance, less the current. And generally metals which are and which have more resistance are called by the name resistor. Right? Now this is what the resistance or resistor which I have shown you. Right? I will close it a little later, because why it is closed in a plastic socket, because when the current is flown into the resistance, it becomes hot, and that's why usually it is surrounded by a bad conductor of heat. Right? So more the resistance, more is the heat produced, and that's why to avoid any injury in our fingers, we are always closing this with the plastic one. So rest of the other assembly I'll do little later. It will take time in this video. So this is about resistance. And resistors need not be always of this size and shape. Okay. I'm going to show you a different values of different resistors. You can see this. There are many small resistance of each 100 ohms. Right? So this is also a resistor. Okay? They are all used in physics practicals, particularly electronics. See this. This is 2.2 ohms. In the same way, right? So this one is 1 kilo ohm. That means 1000 ohm. And you just see that these resistors are given some color bands. Okay, by which the value of the resistance can be understood, which we'll tell you a little later. Okay, since the number is given here, we can say that it's a 1 kilo ohm, but without that also we can understand the type of band, the color band, and we can find out. Okay, there is a chart to understand that. So these are all, the resistances of different values. We require this for different experiment. Right? So resistance can be, or resistors can be of any shape. Okay, but in physics practical, as far as Ohm's law is concerned, okay, we need to have, okay, you will be given generally this type of resistors. Right? So we have completed bit of understanding about what is resistance. Right? Now we'll go for voltage. Right? So what is voltage? Let me take a new paper here. Voltage is work done, or potential difference it is called. Actually it's a work done. But work done to do what? To carry unit positive charge. Okay, it's a work done by charge. If you can make W for work done, Q will be for charge, coulombs, and here joules. So V is equal to W by Q. Right? This is about voltage. I'm not telling in detail the derivations of all those things. But one thing you have to remember, voltage is measured in volts. And what is volt? Volt is joules per coulomb. Okay, joules. And why joules? Because it's a work done, and Q for coulomb. Right? So I am just showing an arrow mark, and this arrow mark represents work done is measured in joules and charge is measured in coulombs. So joules divided by coulombs will give rise to volt, and that's why it's called voltage. And how can we measure the voltage? We have a device here, right? This is, just look at this. There is a V letter which is written on this, and this is called voltmeter, not voltameter. V-O-L-T-M-E-T-R, voltmeter. Right? Now what does it do? It finds out the voltage between the 2 points. And what does it mean? Let me show you on paper. Let's say that there is a resistance here. For example, this is the resistance, and resistance is denoted by the symbol. So this is the resistance. Okay, this is the resistance. Now I have 2 points here, A and B. When I supply current, how much of voltage will be developed in between these 2 points? How much of voltage will be developed between these 2 points? And that is measured with the help of voltmeter. Right? So look at this voltmeter carefully. The moment you find a voltmeter in your hand, focus on what is written here. It's a V. V stands for voltage. After that, you have to look at the first value, that is 0, and see that whether this needle is at 0 or not. Okay? Sometimes it may not be at 0. And look at the next value here. Sometimes we read it as 5 and say 5 volt. It is not 5, it is 0.5. And therefore, it continues from here to 0.5 and then 1, 1.5, 2 and 2.5. Look at it very carefully. Right? And then find out what is the smallest value this device can measure. What is the smallest value this device can measure? For example, you see, from here to here we have 0.5 volt. So let me write 0.5 volt, right? And then how many divisions are there between 0 to 0.5? You have to count here 1, 2, 3, 4, 5 and then another 5. 10 divisions are there. So 10 small divisions together is 0.5 volt. Right? Look at this again. And what will be the one division here? So basic mathematics, 0.5 divided by 10, which will give you 0.05 volt, which means that smallest part, okay, is 0.5. And therefore, when each division is 0.5, how many such divisions are there here? 10 divisions, and therefore it becomes 0.5 into 10. Understood? 0.05. 0.05 into 10, which will become 0.5. Each division is 0.5. Understood? And what do you call this smallest value which is possible to measure in this? Remember, this is very important. This is called least count. So the word itself will tell you the meaning of this. Least count. The least possible value available in this device is 0.05, which is the least count. Now this is the first thing which you should remember before you go ahead with the Ohm's law or any practical where the measurement is going on. Right? So what is the least count of this? 0.05 volts. Right? But not always all the voltmeters will be having same least count. Let me show you one more voltmeter, and here I have, look at this. Here also it is written V. So it's a voltmeter. But now we will find out the least count of this. Right? So what is the least count? I'm going to turn this page down. Look at this. And how to find the least count? First value is, look at this. This is slightly, this instrument has an error. Right? Because it has, the needle is just ahead now. It is not at 0. Okay? Either you have to correct it by opening it and just tightening the screw, or repairing it, or we have to consider that value and minus it from the final value. Okay, but before that we should know what is the least count of this device. The first thing you have to do is find out the least count. Now look at this, from 0 to 2, it's a 2 volt, 4 volt, 6 volt, 8 volt and 10 volt. So from 0 to 2, how many divisions are there? There are 10 divisions. So 10 divisions is equal to how many volts? 2 volt. So 1 division is equal to 2 by 10, which is equal to 0.2 volt. So this is the least count of this device, this voltmeter. Now look at the difference. This voltmeter has got 0.05 volt as a least count. This measures till 0.05 volt, where this measures only 0.2 volts. So which one may be more accurate? So this will be more accurate because this will measure the smallest of the smallest, 0.05 volt. But wait a minute. Sometimes your supply of voltage will be more than 5 volts or more than 10 volts, where this will measure only till 3. This is 2.5, 3 volt. So that time this will not be of any use. So it depends of how much of voltage you supply from one end. Okay, whereas suppose if the voltage you supply from one end is around 12 volts or more than 10 volts, you can use this because this measures till 10. Having understood what is the least count and how can we find out the least count of any device, right? Now let us find out how can we connect these two. Right? But before that, see here, every voltmeter has got 2 terminals. So red always is positive. Even if this positive is not written here, remember red is a positive and black is always negative. This is the same with every electrical equipment. You can even find here, you can see from far it appears both black, but it's actually a red here. Okay, and this is the black. So this is positive and this is negative. Right? Now I'm going to tell you how can we connect this. Let's say I have a resistance here, or it is better to take one resistance somewhere from here, because I have already opened this, so it doesn't look good as a resistance, right? So what I do is I'll take out one resistance from this box. I'll open it, look at this, and then take out one resistance here, and then keep it here. This is also a resistor, right? I'll keep it aside. So this is the resistance, right? So I'll take it here. Okay. Now this resistance or resistor is given a symbol like this, as I already told you. And that means if this is a resistance, this has got 2 points, right? Let's say this is point A and this is point B. Now we have to find out what is voltage. And voltage is always between 2 points. We should not say voltage at this particular point. No, voltage is always between 2 points, because it's the work done to carry a charge from one point to another point. So always 2 points to be referred. And therefore, we have to connect this resistance to the voltmeter this way, which means if, for example, I'll just pull this here down, this is the way. Okay, which means if I can give a symbol, let me write a symbol of voltmeter. This is a symbol of voltmeter. Plus and minus, this has got plus and minus. So I have to connect here a voltmeter. Let's say this is plus and this is minus. This much you have to understand. Okay, this is the resistance, this is the voltmeter, and this voltmeter should be always connected across the 2 ends of the resistance. I'll repeat this. Voltmeter should be connected across the 2 ends of the resistance to find out the voltage across these 2 points. Right? So we have learnt about voltmeter. Well, we have learnt about voltage and voltmeter, how to connect between the resistance, and what is left now is to understand current. Now we have crossed 20 minutes now. We will learn about measurement of current in the next video tutorial, and then we'll continue with connecting all together and find out the voltage as well as current to demonstrate Ohm's law. Thank you. Please be connected. Thank you very much. God bless you.